Okay, so we're starting section 1.5. We'll take like a day and a half, I guess, to do 1.5 because we'll do part of it today and finish it tomorrow and then start on 1.6 tomorrow. 1.5 is solving quadratics, but there's 4 different ways that you can solve a quadratic. There's actually 5, but we don't solve by graphing because that requires you to graph, which y'all don't like, which we will graph some quadratics, but we're not going to solve by graphing. You also can only use the graphing method if it has like really pretty answers, because otherwise you're just kind of guessing. So we'll learn the 4 algebraic ways in this section. And the first one we're going to learn is to solve by factoring, which is why you need to know the zero product principle or property. Okay, so a quadratic equation is going to look like this when it's in general form. Basically, for a quadratic, you want an x squared as the biggest exponent. The zero product property is what allows you to solve by factoring, because once you factor, you have to be able to set your factors equal to 0 and solve, and that's allowed because we have this property or principle that says if you multiply 2 things together, then one of those things is 0. And with a quadratic, they both are 0, but with different values that cause that to happen. All right, so some steps to solve by factoring. You're going to make sure that you have everything on one side equal to 0. You're going to be in general form. And then you're going to factor. Then you set your factors equal to 0 using that zero product property. And then you solve those little equations. And then we're not going to check our solutions because you only have to check if you are working a problem that could have extraneous solutions. And quadratics don't have those. You can check if you want, but I don't really require that because I don't like to do it. All right, so to solve by factoring, you want it equal to 0. So this first one, they've made that step is done for you. Here we have 2 terms. They look like they have something in common, so I think I can take out a GCF. So we're going to take out 3x and have x minus 3 left. With the quadratic, when you solve by factoring, you either have a GCF, a difference of squares, or you can factor by guess and check because you have 3 terms. All right, so once you've done the factoring, you're going to take each factor and equal that to 0, and then solve those little equations. And they're going to be little like 2-step equations at the most. These are both little 1-step equations, so I'm not going to show my work. I will tell you what I'm doing. I'm not going to write it all down. So at this point, to solve this, you divide by 3 on both sides, and you get x is 0 as one answer. Here, you're going to add 3 to both sides, and you get x is 30. All right, so next problem, we are not equal to 0. So first step is to subtract 1 and move it over here with everybody else so that it is equal to 0. So I subtracted 1 on both sides. Now you have 3 terms, so we should be able to guess and check as our factoring method. So let's see, 2x times x and 1 times 1 will give us our numbers. So to get the guy in the middle, if this is a positive and this is a negative, that should work out. So positive 2x here, negative 1x here, and we know we need different signs because that guy's negative. All right, so then set your factors equal to 0. I'm recording this video at home and I'm using a little writing tablet, and it is a pain to use because weird things like that happen. No, really stop. So I apologize for the random that's going to happen. Okay, so excuse me. So we add 1 and divide by 2, and you get 1/2. That's a 2. I was doing really good, and now all of a sudden everything is going weird. All right, so you get 1/2 as one of your solutions. Here you're going to subtract 1, and you get -1 as your other solution. Quadratics usually will have 2 solutions because you're really looking at x-intercepts, like where it crosses the x-axis. And since a quadratic is a U-shaped graph, it can cross the x-axis twice. Sometimes it just kind of sits on it and has 1, and sometimes it's like way up in the middle of nowhere and never touches the x-axis. which causes it to have two imaginary solutions, which you don't get by factoring usually. All right, so next we need to get this equal to 0. So we're going to subtract 2x and subtract 20. All right, so if I subtract 2x, it has a buddy to combine with. So if I subtract a 2x here, then I have a minus 11x. If I subtract 20, he doesn't have a buddy, so he just goes on the ends. All right, so again, we're going to guess and check. Then we have 3x and x. I meant to tell you to do 3 and 4 on your own. So if you want to pause the video and try those, finish this one and do 4. All right, so to get 20, we need a 4 and a 5. I'm not sure where I want them. I think this is going to work though. This is 15 and 4. That'll get me negative 11 if I have negative 15 and positive 4. All right, so if we make this equal to 0 and then make this equal to 0, we get subtract 4 and divide by 3. So negative 4 thirds. That's a 4, not a y. Here, if you add 5, you get that x is equal to 5. So negative 4 thirds and 5 are your solutions. All right, here there are two terms. Let's see, I can take out a 2x and have x minus 5 left. So 2x equals 0. X minus 5 equals 0. So here we divide by 2 and get an answer of 0. Here we add 5 and get an answer of 5. All right, so that is solved by factoring. Next, we have the square root property. So this is just explaining what the square root property is. Basically, it's saying that if you have something squared equal to a number, then you can take the square root of both sides and you get two answers, the positive and the negative square root of whatever's in the place of d. All right, so steps for using the square root property. You have to get the squared term alone. That's your first step. And then you take the square root of both sides. Don't forget to put plus or minus. And then solve if necessary, which will make sense when we work an example. All right, so to solve using the square root property, we want the squared thing by itself. So when I say squared thing, in this problem and this problem, you just have an x squared. But in these two problems, you have parentheses squared. So the square root property, by the way, will only work when you have problems that look like these. If you have problems that look like these guys, the square root property won't work because you can't get to that x by itself. All right, so when you have one like number 5, you're going to add 21. And then divide by 3. And now you're in the place where you can use that square root property. So you're going to take the square root of both sides. You introduced the square root to the problem, which is why you have to put plus or minus on your answer. The square root of 7 is a yucky decimal, and 7 is prime. It will not simplify, so you are done. But you have two answers, whatever the positive square root of 7 is and the negative square root of 7. Both are nasty little decimals. So we leave the exact answer. All right, so next we are going to subtract 45. Divide by 5. And take the square root of both sides. So you took the square root, so the next step is going to have a plus or minus. All right, so now the square root of 9 we know is 3, and because it's negative, we know we have to put an I on our answer. So we get two imaginary answers here, positive 3i and negative 3i. All right, so number 7. Your squared term is already by itself, so you're just going to take the square root of both sides. X plus 5 comes out because square root and squared are inverses. They undo each other. You put the plus or minus, and then the square root of 11 doesn't simplify and it doesn't have a square root. So it just looks like this. This is where that last step of solve if necessary comes into play, because we don't know what x is yet. We know what x plus 5 is. So we're going to subtract 5 on both sides. I'm going to show this one time. So you have x, and over here you can't combine these. So you're going to say I want to do -5 plus and minus the square root of 11, which gives you two different gross little decimals. All right, so number 8, you have this parentheses squared. You've got to have it by itself before you can take the square root. And if you tried to work this out, it would just make it uglier and make you like work yourself in circles. So there's no point in multiplying anything. We're going to add 7. Then we're going to divide by 2. Then we take the square root of both sides. So the square root of 9 is 3. Remember to put your plus or minus. And x minus 4 just comes out. So at this point, again, you're going to add 4. But what you have to think about is that you have two things happening here. So we have x minus 4 equal to 3. And we have x minus 4 equal to -3. That's what this actually says. There's no point in writing it over here because you don't know what the square root of 11 is. But since we know the square root of 9 is regular old 3, then I can get two answers here. So if I add 4 here, I get 7. If I add 4 here, I get 1. So the fact that you got two pretty answers here means that if you were to have multiplied all of this out, it would have been factorable and it would have worked out. But that's a lot more work than is necessary when this gets the job done. All right, so that's 4 examples of how that guy works. Okay, so the next part is completing the square, which completing the square is going to lead us to problems that look like this. So it's really just more of this, but with an extra step. So before we can talk about how to solve by completing the square, we need to understand what that process is doing. So a perfect square trinomial is when you have a trinomial that when you factor it, you get the same thing twice. So it's something squared gave you that. That's what makes it a perfect square. Like 3 times 3 is 9. So 9 is a perfect square. Well, 8 minus 8 times 8 minus 8 gives you this guy. So he's a perfect square. He's just an ugly perfect square. So we're going to, first of all, just practice how do I make this happen? How do I force something to be a perfect square trinomial? So if I just give you this part, what magic number goes here to make it factor pretty? Well, if you look, do you see how if you take half of 16, you get this number? And if you take that number and square it, you get this number. Well, that's the process every time. So if I take half of this, I get +6. So the factored form would be x plus 6. So this magic number would just be 6 squared, so 36. So factored form here, half of -20 is -10. If I square that 10, I just get 100. All right, so that's completing the square. Now we're going to use that to solve. And what we're going to have to do is get the variables on one side and the numbers on the other so that we have something that looks like this so that we can do this complete the square piece. So we complete the square and factor, which is what we just did on those last two examples. And then we're going to solve using the square root property. Don't forget plus or minus has to happen. Okay, so here we go. For this problem, the first step is we need 7 to be on the other side. So when I move my 7 to the other side, I'm going to set myself up to complete the square. So I need a plus blank. Well, if I randomly add a number on this side of the problem, I'm going to have to add it to the other side. And then we want to know what this looks like factored. So to get this number, we're going to think half of 6 is 3. So that's my factored form. 3 squared is 9. So 9 goes in both of these blanks. So we have completed the square. We just got to make sure we add these together and just get a 2 here. Now you have a problem that looks like the square root method will work. So you're going to take the square root of both sides. So x plus 3 comes out here. On the other side, you have plus or minus the square root of 2. Last step, subtract the 3. And you can't really do anything but say, I want to know what -3 plus or minus root 2 is. Okay. So number 10, you have the work to do. You've got to get your x squared and your x by itself. So we're going to subtract 6. 6 has something to subtract from on the other side. So if I subtract 6 from 8, I get 2. All right, so completing the square and factoring, we know we want x minus 5 as the factored form, which means square the 5, 25 has to go in the blanks, which gives me 27 here. All right, so now when we take the square root, we're going to have x minus 5. We need plus or minus. And then this guy simplifies to 3 square root 3. So come up here and let's look at why that is. 27, remember, is 9 times 3. And the square root of 9 is 3, and the square root of 3 is not perfect, so it stays. All right, so then we add 5. But again, we can't actually add 5 to this thing, so we just say 5 plus or minus 3 root 3. All right, I would say pause and see if you can get the next two. And then unpause and check and see how you did. All right, so 11, we need this x to come over here. So if I subtract x, that's going to make this negative 4. And I need 5 over here, so add 5. So we have a plus blank equal to 5 plus blank. Here we're going to do x minus 2 as our factored form. 2 squared is 4. We have 9. Take the square root of both sides. And you get x minus 2 is equal to plus or minus 3. So then we have to add 2. But remember, we're adding 2 to 3 and negative 3. So we have 3 plus 2 is 5. And negative 3 plus 2 is negative 1. All right, so number 12, you're going to add the 5. Remember to set yourself up for completing the square as you go. So put your plus blank, add 5 to 1, and that's 6. So this will factor to x plus 6 squared if this is a 36. Let's see, what's 36 plus 6? 42? I don't think that's what I wanted that to work out to be, but it's okay. All right, so take the square root of both sides. And we get x plus 6 is equal to plus or minus. And I'm thinking the square root of 42. We can do 6 times 7, but those aren't perfect squares. We can do 2 and 21. Those aren't perfect squares. So I don't think there's anything you can do to the square root of 42. It's just going to have to stay. So then you just do minus 6 plus or minus root 42, and you are done. All right, I believe that's it for today. Make sure that if you have questions on that assignment that you let me know. I'm happy to help.